has become clear to me for this class, this is my segue, isn't that beautiful? Um, is that we're moving a bit slower than I expected, and so there may be some stuff that we have to cut from the end of the course. And I was looking at kind of the syllabus and learning objectives, and the things that I think could be cut is the making your own website using R, and that's kind of the last 2 weeks. And so I think rather than try to push ahead too fast to where people get left behind or we're not understanding things correctly, I'm just gonna be okay with moving things a bit slower. And so if we're a bit behind on something and we need more time, I say we take it, okay? Because learning the nuts and bolts of how to work with R and learning the really cool parts, which is taking a data set that you're working with as a scientist and turning it into pretty pictures and doing a model test on it, that's the important stuff. And so that's not going to get left out. But if we do have to leave something, it's the website. I can send you a link to a tutorial. That's how I learned to do it. By the time you're done with this class, it'll be easy enough for you. You just won't have me standing over your shoulder. Is that okay?
Thank you. It sounds great.
Okay. So today, what I want to cover, I always write out a little like sheet of paper and I like to check stuff off when we get there, and it never quite works out. But here's what I hope to cover today is R packages, what they are, how to install and load them, and then move into logical operations, so asking true-false questions about a vector, and then using those logical operations with a new package in order to subset stuff. Okay, that's going to make things real easy for us going forward, because next week, if we covered those three things, we're going to be ready to start making plots. Subsetting on the fly won't be an issue for us. So those are the main three things that I want to cover today. If we don't cover them, it's not the end of the world. We'll do them on Monday, all right? So just wanted to kind of keep you in the loop as to my thinking on this course and where we might be slowing down and kind of spending more time on stuff. Okay? It's important to me that everything we learn is solid for you. And of course, some of that's up to you. You have a responsibility to spend quite a few hours a week messing with this, but some of it is my responsibility, and that is to make sure that we're moving at a pace that works for everybody, especially online. All right. Let me bring up RStudio. You should do the same. I'll share my screen with you. Okay. Is that working?
Yeah.
All right, cool. Now I'll make this bigger text so you can see it. And that is just Control Shift equals, so it's like Control plus. And that makes the text bigger. Okay. We'll make it nice and big. Now, like any day, anytime you're using RStudio, the first thing you do is open a project. So I'm either going to click here, Open Project, or I'm going to show you a fast little shortcut. Over up in the top right, there's a little box with R in it, and it says Project None. Do you see that? Okay. If I click on that, it shows me my last 10 most recent projects I've worked on, and so it's just a little shortcut to get to them. So for this one, there's data courses on there. I'm going to click on that. Since we're not really working in assignment 3, I'm not going to go to assignment 3 project. I'm going to data courses on. And it'll say like switching to project, and then boom. You'll see it at the top right up here. That shows me that I'm in a project called Data Course On.
Sorry to have a question so fast already, but
Great.
I just got Air starting R said air starting R. The R session failed to start. Error message, none available.
Well, that doesn't really give me much to go on. Close it down, open it up again, see what happens.
I'll keep trying.
Mine did that to me on Monday a couple times. I just kept closing it and opening it, and it worked eventually. So.
Okay.
Dr. Zahn,
Yeah.
how do you get the Git tab to open? I mean,
You have to be in a Git repository and an R project.
I don't have that tab. I don't have that Git tab. I mean, I can push everything through the terminal like I did on Monday, but it'd be nice.
All right, so if you don't have the tab, you're not in a Git repository using an R project. The tab only shows up in that case. So let's try a few things. Try this, git wd, open close parentheses. What do you get there?
I get my path, so users. I'm in a Mac, so
okay.
I have users, then my username, and then desktop, and data course, my last name.
Okay. Now, open up your terminal. All right. And move to that. So be in that directory and type in git status.
Okay.
What do you get when you type in git status?
I get basically the same things you get, so
okay.
And all
okay.
That.
So you are in a Git repository. That's cool. I'm just going to go ahead and close the terminal here. And then you are in the R project data course Castillo.
Yeah, I am.
Okay. And still no Git tab?
No, I only see a tutorial tab.
I am sorry to say that I have no idea what's going on, but it shouldn't be a big problem if you can still push using the command line. And if you got time after class, we'll do a share screen and kind of like work it out.
Okay, thank you.
Right. This is kind of what happened to mine on Monday, and I'm on a Mac too. So I'm trying to remember. Does yours have desktop? Like if you go to your files, does it say desktop and then your? Yeah. Do you see how his says desktop and then data course _ on? Does yours have desktop, or does it just go straight to data course _ on?
It does have desktop. Yeah.
It does have desktop.
Yeah.
Okay, because that was the problem with mine. Is I had just created an extra.
Yeah, you had like 2 versions of your repository.
I guess maybe yours isn't.
Oh, yeah, we'll figure it out later. Thank you.
All right. Yeah, I got time after class, so we'll do it then. Okay. So here I am in data course on as my R project. Okay. Let's open a new script, a nice blank one. The shortcut for that is Control-Shift-N or Command-Shift-N if you're on a Mac. Control-Shift-N. The long way to do it is to go up here, File, New File, R script. All right. So remember, an R script is this in the top left. It lets you type in commands, run them interactively with Control-Enter. It lets you kind of like troubleshoot, debug, and everything. When you hit Control-Enter, it actually sends it down to the bottom to this console, and that's where it's running the R commands in the background, but we can compose them up here. Okay, so first up, let's bring up our iris dataset. How do I call for that? It's data, and then in quotes, iris. So that's our just built-in iris data. If I just want to look at it, I can say iris and hit Control Enter, and it spits it out down here. So if you remember this one, that's the sepal and petal lengths for 3 different species. Okay. So somebody tell me in plain English how to subset this to the first 5 rows, just the sepal width. Just want to look at the first 5 observations of sepal width in this data set.
Okay, so I spent many hours trying to do it without using numbers to only realize that I don't think we can do that yet. But
those hours were not wasted, I promise.
I feel like they were. I read a lot of stuff that didn't make a lot of sense online.
Hey, that's the starting point. It's good. This is what we do. It's what I still do as a professional R user. I read a lot of stuff online that doesn't make sense. So don't feel bad. You spent those hours wisely.
I'm glad I'm not the only one.
Essentially, what I did is, you want just the 1 through 5 of what again?
Of the sepal width column.
Okay. Sepal width. Oh man. Never mind. Maybe I have forgotten already. I know you can do in brackets 1 through 5. The 1, through 5. So that's a starting point.
Right.
Now we need to specify that it's sepal width, though.
Mm-hmm.
So to do that.
So remember, since iris is 2-dimensional, it's got rows and columns. It's not just a vector. We need to give it the rows and then the columns. So we need a comma right there.
Oh, well, yeah, and then whichever column is sepal width. Is that 1, 2? Oh, sepal width, if we're looking down at the bottom, is 2. Okay. So that'll do it.
That should do it. Yep. 3.5, 3.0, 3.2. Let's go up to the top here and check it out. 3.5, 3.0, 3.2. That is the first 5 rows of just that column. Now we could also specify this by saying 1 through 5, comma, sepal width, in quotes. And that's going to give us the same thing. This second way, using the column name, is a bit safer. In case the column order changes, that won't throw you off, right? Because if you rearrange these columns like externally in an Excel spreadsheet or something, and suddenly sepal width was over here in column 3, this code would give you the wrong answer. And so whenever possible, it's safer to use the name of a column. Another way of doing this, see if this one makes sense, iris, $, sepal width, brackets 1 through 5. You get the same answer from that. Why did I not put a comma here?
Because you're only specifying the column sepal width, which is it's a vector, right?
Vector, 1-dimensional, and so we just tell it which positions we want in that 1-dimensional vector. So yeah, there's 3 ways of doing the same thing right there. We're going to learn even more. Unfortunately, in R, there's always like 76 ways to do every possible task. I'm going to try not to overwhelm you with all of them. I want you to see these because these are built into the base R. They'll work no matter what packages you have loaded. But we're going to install our first package now.
I have one quick question.
Yeah, please.
So in the second one, for instance, where we did iris 1 through 5, well, in our homework, we had to do 1 through 50 and then 101 through 150. For that, I used a vector, but is there any format in which you can do it without a vector, where you can maybe stick in 2 things with a colon between them?
To accomplish what?
So to make list 1 through 50 and then 101 through 150.
Yeah, let me show you. So let's say we wanted, I'm going to put a comment here. We want rows 1 through 5 and rows 10 through 15, something like that. I can use C to concatenate those together. 1 through 5, comma, 10 through 15. And then, what is that, number 2? Yeah.
All right, I think I actually tried that, but I never got it to work. Probably a format issue or, syntax.
I bet you were missing a comma right here, or this close parentheses right there. That'd be my experienced hunch. So essentially, we're giving it a vector to use, and we're saying, hey, stick the numbers 1 through 5 together and the numbers 10 through 15. If I just highlight that part, the C, and what's inside of it, and hit Control Enter, you'll see that it just spits out those numbers. 1, 2, 3, 4, 5, 10, 11, 12, 13, 14, 15. Okay, so that's how we're telling it exactly what rows we want.
Okay, so that's super useful. I wish I would have done it that way. But is there a way to specify the species, like we were doing for the homework assignment, using the species name instead of just saying, oh, row 4, take 1 through 10? Because I tried doing the species in quotes, and it didn't recognize that because it wasn't a column name at the top.
Exactly.
So I was like, how do I specify data inside of, the rows columns?
Yeah.
Does it recognize even anything in there?
It does. It knows all about it, but it wants you to ask it a yes/no, a true/false question.
Okay, so I tried messing around with some of that.
Let's look at our inequalities here. Let's make ourselves a little vector. I'll call it vec. And we'll just say that it's 1 through 10. Boom. So I've got vec up there. It's the numbers 1 through 10. Vec is greater than 2. Go ahead and hit Control Enter on that. And look what it gives me. Hopefully that makes logical sense to you. Is 1 greater than 2? False. Is 2 greater than 2? False. Is 3? True. The rest of them are true.
Some way to ask it species equals setosa or so?
Yeah, I'm gonna get there in just a second. Let's learn all of our inequalities. Vec is greater than or equal to 2. That gives us only 1 false. All right. Vec is greater than or equal to 7. Right? There's 7, 8, 9, 10. Now, if you want to ask R, is something equal to something else? This is a bit annoying, but you say vec double equals. So a single equals vec equals A in quotes there.
That'll make vec equal to A.
Yeah. Exactly. That makes vec equal to A. There it is. So I ruined it. I'm going to delete that. Go back up here, run this line, so vec is now again equal to 1 through 10. The double equals, I want you to read that in your head as is equal to, question mark. Vec is equal to 5. False, 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 false. True. False, 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 false. Okay, with that in mind, let's look at this. Iris $ species is equal to Setosa. I have to put it in quotes. Why?
Because otherwise it's going to treat it like a number, and it's not a number. Or
It'll treat it like an object. It'll look for it over here. So what it's doing now, just like vec is a vector, iris $ species is also just a vector, right? It's this column. It's one-dimensional. It's going to return, I'm guessing, since I know this data set, 50 trues and then 100 falses. Look at that. Okay, so those are the rows that are Setosa. I could save that as Setosa rows if I wanted to. Setosa rows.
Then you could somehow do for each one that is true, put it into a new vector so that you can view just Setosas. Or
you're going to
like
love
that.
this. You don't even have to tell it for each one that's true. R automatically understands what true and false is about when it's subsetting. It loves it. Being a vectorized computer language, if you're into computer science, this is actually kind of rare. You don't even have to say that. You just give it iris Setosa rows, comma. That means just pick those rows. This is a list of true false, the same length as our vector or as our data set iris. So those are the rows we want, and then the comma means, okay, here's the columns, and if I don't put anything, it means all the columns. So that's a nice little shortcut. And there it is. So here we are using inequalities. You're going to be using these like all the time in R. Inequalities or equalities, I suppose, also. But these are logical questions that we're asking about our data, whether something is greater than, equal to, greater than or equal to, or is equal exactly this word. So here we broke it down into 2 steps. We found the rows. Setosa rows itself, though, is just, if you go up here in the top right and look at your global environment, what type of variable is stored in there? It's not numeric. It's not a character. Any guesses?
It's a Boolean.
It's a Boolean. In R, we call it logical. That's how it is stored. And so LOGI here stands short for logical. So this is just true, false. As a matter of fact, the words in all caps, true and false, they change color when you type them. They are special words that you should never use for anything else. If I hit Control Enter on true, it says, yeah, true, you're right. It's just yes. If I say false, it says false. If I say true plus false, what do you think I'm going to get?
An error.
No, it gave me the number 1. Let's try this. 1 plus true. 2.
It's because true is stored as a 1, evidently, and false is stored as a 0.
That's it. This is how computers work. This is your ones and zeros, right? Okay, true is stored as 1, and it actually counts as a number 1. Okay. So check this out. We've got, Setosa rows. Remember, that's this list of true and false that we created. I can actually wrap that in a function called sum, which does exactly what you think it does. It adds everything in there, and it gives me the number 50. That is how many rows matched this condition, where species is equal to setosa. 50 is the answer. Okay, so I gave you a bit of an assignment, which was, wait, wrong class. To look at logical operations. Okay, make sure you go through this and that each one of these makes sense to you. Okay. Here we're using a new data set called MT cars, so you can just look at that. If x is 1 through 10, x is greater than or equal to 3, that should make sense to you. Okay. Make sure that all of these make sense to you. We've got a couple extras we haven't quite mentioned yet. The greater than, less than, those are pretty straightforward. The is equal to, that one's pretty straightforward. It's kind of hard to remember at first until you get used to typing equal equal. But this last one here, percentage in percentage. Let's take a look at that. 5% in percent vec. What am I asking this? That's a question that I'm asking R. What does it mean in English? Given
You're
that,
asking if the object 5 is in your vector vec.
yes. Well, not the object exactly 5. In this case, it's just the number 5, but yeah. We're asking if 5 is found anywhere inside vec. And the answer was true.
So here's a question.
Mm-hmm.
If you wanted to compare two vectors to each other, if you said, is vector 1 greater than vector 2, if you just put it in straight as that, would it give you like 100 trues and falses, 10 for each one of the numbers?
Yeah, so let me show you. I'm going to do sepal length greater than iris petal length. 150 true falses. In this case, they're all true, it appears to be. So it's going to take those vectors, line them up side by side, and do comparisons across each value. So it said, is the first thing in sepal length greater than the first thing in petal length? Yes, true. All right, what about the second? True. And so on all the way down. This is really pretty useful behavior for a coding language to have if it's being used for data science.
So what if on purpose you wanted to compare every single number in one vector to every single number in another vector one at a time? Or
well, we just did exactly that with this.
well, like you want to do number 1 inside the vector to number 1 inside the first vector, then number 2 to number 1 inside the first vector, and so on until you go through all the combinations you can get, more or less.
Okay, so you want to look at the first number of sepal length and compare it to every value of petal length, and then the second number of sepal length and compare it to every value of petal length?
Yes, and then get a whole lot of trues and falses.
Iris, $, sepal length, 1. That's the first number in sepal length. Is it greater than iris, $, petal length? So there, we've just compared this first value of sepal length to every possible value of petal length. A bunch of trues, and then we get falses down toward the end.
And then you could, for instance, make a loop that increases sepal length by 1 every single time until it hits some max number.
Yeah, I don't want to get too sidetracked, but if you've gone through the exercises, you would just write a little for loop. Like that. Yep. Okay. But I want to learn a new way of applying these logical expressions for subsetting. Okay, you've seen it's pretty powerful here. We made some Setosa rows, the rows where species is equal to Setosa, and then we use those to subset. Okay, knowing that and knowing this funky little command, which gets easier to type the more you do it, how would I subset this to where it's just Virginica and Setosa rows?
You could can you concatenate to Setosa rows and Virginica rows together?
So let's see here. Iris species in concatenate iris. How would I do that?
I will work on it and I'll let you know.
Okay.
Can you use an or somehow if it's equal to one or the other?
Yeah, I could do that. I could say is equal to Setosa or, which I picked up from the lesson and the exercises, or iris species is equal to Virginica.
But that's an or. Wouldn't you want an and?
No, there's not going to be anything that is Virginica and Setosa, would there?
Okay. Oh, yeah, because there's not both.
Yeah.
All right.
I could do an and there, and it's going to give me a bunch of false. But what was a pipe in our command line is now the symbol for or in R. So that's one way. Or sounds funny now. I could say iris species is in, and then make a set. Setosa Virginica. So we gave it a vector right here. We said, here's a vector of length 2. It contains some text. The first item is Setosa. The second text item is Virginica. All right, now I'm going to take iris, look in the column named species. Oops. Control Z. The column named species, and go through one at a time and find out if those are in anywhere in this vector. And it did that. It's true, the first 50, and then the next 50 are false, and then the last 50 are true.
So I thought that the equals was asking if it's equal to, not assigning it to
Right.
just look for that.
Let me read line 38 in slow English for you. See if this helps. Iris, column, species. That's a vector. Is it equal to Setosa? Or is iris, column, species equal to Virginica? If I run this line, it gives me the same output here. It looked in there, and the first thing it saw in iris species was, I believe, Setosa, right? Yeah. So it found Setosa in position 1, and I said, is it equal to Setosa? And it said true. And then I said, or is it equal to Virginica? It said false, but that didn't matter since I said or instead of and. As long as one of those is true, it's going to return true. So if I wanted to subset iris to just Setosa and Virginica, I would do one of these lines. They both return the same thing. And I would just save it as something, set ver, and then I would say iris set ver, comma, there it is. There's my entire data set except for, what's the second one? Versicolor. So we left Versicolor out. You want to see a third way of doing this? This one can come in handy. Iris, $ species is not equal to Versicolor. So exclamation point equal means is not equal to. So it finds number 1. Is Setosa not equal to Versicolor? Well, yes, it is not equal to Versicolor, so it says true. Okay. Make sure you practice these logical evaluations. They need to be on your fingertips, ready to use. But I'm going to show you your first package. Let's install it together because this makes working with data frames much nicer. All right, I'm going to go over here to Packages in this little tab. It's going to bring up some stuff. Then I'm going to click on Install. This lets you install collections of cool functions that smarter people than us have written. Okay? So there are people who spend their time writing really cool R code and putting it together in a little package and sticking it up online. And RStudio gives us a nice way to download these so we can get functionality out of R that we don't have to reinvent ourselves. So these packages just come with a bunch of functions. There's the, the sum function that's already built into R. Length function is built into R, but we want a package called tidyverse. If you start typing that in there, it should pop up. Go ahead and say that. Make sure that install dependencies is checked, because some of these packages require other things. Oddly enough, some of them are even running like old Fortran code from the 1950s. It just happened to work well for them. Some of them are written in C++. So install dependencies and then click install.
All right, real quick, how did you get that screen to pop up?
All right. It's down here. We got files, plots, packages.
Okay.
And then install.
All right.
Tidyverse. All right, go ahead and install that.
You can also use the install.packages command, right?
Yeah, look, it actually will print it out down here at the bottom. In the background, you clicking on all those little things actually ran this little bit of code here. Install.packages tidyverse.
So when I was messing around with the assignment, I came across packages, and it said for Windows I had to download an installer to get packages, and so I did that. Did that do anything? Did I even need to do that?
I don't think you needed to do that for most packages.
Okay.
For some packages, they're actually not up on the R website. We call it CRAN. And as you can see, like install, it says install from repository CRAN. That's the acronym for the Comprehensive R Archive Network. Any package that's found on CRAN means that it has a publication, peer-reviewed publication associated with it. It's probably written by professional statisticians or coders, and it's been tested thoroughly by thousands of people and probably doesn't have any bugs in it. It's definitely not like infecting your computer with malware or anything. It's kind of like a trusted source. And so the install.packages feature works with anything that's on CRAN by name. Okay.
All right.
We can go in and install other people's packages. I've written a package myself. You're welcome to install it, but I can absolutely promise you that some of it doesn't work. That's why it's not up on CRAN. Okay, and so once a package has been thoroughly tested, it can get stuck up on CRAN. It's kind of like a mark of approval, and it gets easy install privilege.
So, question: when I did that for mine, it said installing all this stuff, and then it says there's a binary version available, but the source version is later. And then it has another little sentence that says, "Do you want to install from sources the package which needs compilation?"
Yes.
So I should just click
Yeah.
yes. Okay.
So I don't think Windows gives you that same question, but Mac and Linux definitely do. So here I am. I'm on a Linux. The only reason this went really fast for me is because I actually already have it installed. And so it didn't really have to do anything. Okay. This may take a few minutes. This tidyverse is actually a collection of a bunch of different packages that all work really well together. We're going to be using it a lot in this class. And so essentially starting today and moving forward, one of the first things that any script we write is going to have in it is this command, library tidyverse, and that goes right up at the top. So once this has installed, and if it installed without any errors, let me know, and go ahead and do this library tidyverse at the top and run it.
Run it.
You want us to do that in a new file?
Oh, you can use the same file. It's okay. Just put it up at the top, and then we'll run everything again. It'll be all right.
Yeah, I ran it. It
Okay.
showed some stuff.
No errors?
No
Okay,
errors.
one.
It showed
I
a bunch
had
of stuff.
I had an error, but I think it's getting it fixed. What I mean is, when I hit install, my computer went nuts for a little while.
Yeah.
But now it says, like, it's got a bunch of messages saying successfully unpackaged certain names like MDS or MD5 sums. I don't know. There's a lot
Yeah.
of stuff, but yeah.
All right.
Okay.
What you're looking for, and it may take a little while, but you really want to see this line down here, done tidyverse.
Oh, okay.
And if you get an error, it'll say installation of tidyverse exited with a non-zero error status or something like that. But it may take a bit. I mean, internet connections vary. There's actually quite a bit of material in this tidyverse package. Even when I load it to you, it takes a few seconds on my computer. And it says, oh, attaching these packages. Okay.
I did get something that maybe is an error. It says conflicts at the bottom.
That's
oh, yeah,
fine.
it does on yours too.
Yep. We'll talk about that in just a second. I'll make sure everyone's got tidyverse before I talk about these pesky conflicts. All right, maybe the easiest thing is put your virtual hand up once you've got tidyverse installed and have run this line of code here. All right, while we're waiting, last few people, don't worry, you're not holding this up, it's fine. I'm going to describe what this line is actually doing. This library function goes deep into your computer where R knows that the tidyverse package is installed and stored, and it makes it available to you. All right, so this is a bit different. It's given us a bunch of new commands that we can use in R. That's essentially what a package does. Okay, so by running that line, it's going to say, okay, I'm attaching these packages. Attaching means making them available for this current work session. Okay, we've got the ggplot2 package, and then it tells us the version. The tibble package, the reader package, tidyr, stringer, forcats, per, and dplyr. Okay, so it attached these 8 packages, and then conflicts. What it's saying is that in this dplyr package, there is a function called, that's what the 2 colons mean, filter. That is currently masking the original version in the stats package that also had the same name. You might see the problem with this. If you had 2 functions with the same name and you type in the function, what is R going to do? It's got to pick one. Okay, so what this is saying is that previously, before we loaded this tidyverse suite, we had something in there called filter. Now that we've loaded tidyverse, the tidyverse dplyr version of filter has taken precedence. So it's just kind of warning us, hey, there's some conflicts with the names of your functions. So if you run a function called filter now, it's going to be, let's see, you can see it even pops up and says dplyr right next to it. It's going to be the dplyr version of filter. Okay. And that is, in fact, the function that I want to show you.
Does this mean that the normal help menu down in the corner won't work for this one anymore?
Oh, it does. It'll just bring up options for you. It'll say, hey, do you want to use the dplyr help or the regular stats version? So it'll let you click on which one you want. So that can be a bit confusing if you do question mark filter. It's going to be like, which version of filter do you want help with? Okay. So it found it here in stats. That's linear filtering on time series data. So if you're into finance and trying to predict the stock market, that's the version of filter you want. If you want to subset rows using column values, we want the dplyr version. So I'm going to click on that. Okay. So the tidyverse gives us a bunch of nice ways of working with data. One of those that's real fancy, I really love, is filter. Okay. Usage. First thing it wants is data. This is a data frame or a data frame extension like a tibble or whatever. Okay, so we've got a data frame handy. We've got iris. So I'm going to say iris and then a comma. Okay, then what's it want? Let's zoom on down here. Oh, there are many useful functions and operators for constructing expressions to filter the data. Hey, you know those. Okay, so those are worth looking up. In fact, what's near mean? I can just click on it, compare two numeric vectors. Okay, we'll go back. And we'll go down here and look at some examples. Filter. Star Wars species is equal to human. Using that same syntax, let's find the Virginica samples in our data set using filter. It's the same, we're doing the same stuff that we did up here, asking yes/no questions, right? We want a logical evaluation, but it does a lot of the behind-the-scenes hard work for us. We say, hey, filter function, here's the data frame we're going to be looking at. Here's the name of the column I want you to work with. Select all the rows that are equal to Virginica. Okay. What about Setosa and Virginica? How would I use filter for that?
Could you?
Do a let me just copy and paste this.
It says right there inside the help, though, right below. It just added a comma and another equal thing, and it will do it apparently.
Really?
Really?
Filtering by multiple criteria within a single logical expression. And. Oh, they used a literal and sign. I didn't see the whole thing.
Oh yeah.
I did an exclusion operator, and then where's the color?
Oh, okay. So filter iris species is not equal to versicolor. That'll do it. I could say filter the iris dataset column named species is in concatenate virginica, comma, setosa. We can say filter iris species is equal to setosa, or species is equal to virginica. So just like we did up there, we see 3 ways of basically asking the same question, but we've done it in this kind of tidyverse way, which is pretty nice. I think this is easier to read than doing it like this. To me, it reads more like English. Let's filter some rows in iris where the column name species is equal to setosa, or the column name species is equal to virginica. Okay. In practice, this is probably the way Ernie had it, where I'd say, hey, just not the one named versicolor, because it's shorter to type. All right. But it may not be as robust. If we really just wanted things that were setosa and virginica, if we threw in a third species, we would get it as well if we said everything except versicolor. Okay. So with that in mind, let's move to a new data set. Okay.
Do we need that? Do we need that package for the filter function?
We do.
Okay.
Yeah. As a matter of fact, if I were to close R and then restart it and try this, this won't work unless I've already run this line also. That's why I always put it at the top. Any packages you use go at the top of your script. We got to tell R that we want the filter function, and this is how.
Is there an option to say, hey, when I open R, open these packages with it?
Yes, there is, but don't ever, ever, ever use it. And as a matter of fact, I think we all turned that off together at the beginning.
Okay.
Because you can get yourself into real trouble because your code is working. Then you give it to somebody else and they don't have RStudio set up exactly the same way, it will break on their computer. You need everything needs to have a line of code for it.
That lets them know that, hey, I'm using this package.
So then if they try to run this and they get an error, it says, hey, you need to install tidyverse before you can run this code. Then they can do that. Yeah. So let's not speak of that horrible option. All right. So let's load a new data set real fast. And this is what I want you to practice on. Data MT cars. Question mark, MT cars. Motor trend car road tests. This is another famous data set that people use to teach R. There's a reason we use these, because they're actually quite useful. They're nice and small, and they let us practice stuff. We're going to move to big, annoying data before you want to. But for now, we're sticking with Iris, MT cars, and a few others. I want you to practice subsetting MT cars based on a bunch of random stuff. Okay, let's take a look at it. We now have a new little feature called Glimpse that came in Tidyverse. MT cars. And it spits out a neat little summary for you. We got 32 rows, 11 columns, and then it tells you what each column is named, and what type it is. Okay. These are all numeric. They're listed here as DBL for double, which is identical to numeric in R. There's no short form for floating point decimals. Okay. So let's subset this stuff. First up, while we still have like 15 or 20 minutes, subset MT cars so that we only have rows that match horsepower greater than 100 and let's see here, displacement less than 150. And we want to use the filter function from Tidyverse. All right. Anyone think they've got it?
So I haven't typed it all out yet, but my idea was to, so you got the beginning there. I was going to make horsepower a vector saying, hey, take the column horsepower and then any row, and then throw that in there, and do the same thing with DISP, take that column using any row, and then specify it after it's in the filter. Say, okay, so then we have the vector HP, the vector DISP, say HP or DISP. Oh, no, I would have to do that
I see where you're going with this, but you actually don't need to. You're trying a bit of overkill.
Okay.
That's the point of this filter function, is that it reads almost like a natural language. Watch what I'm going to do. You're going to love this. I'm going to copy that. I'm going to paste it in right here, and I'm going to change that and to an and sign. That's it. Where horsepower is greater than 100 and where displacement is less than 150. We got 3 whole rows there. Let's check them for sanity. Horsepower, 113. That's bigger than 100. 175, 109. Okay. Displacement, all less than 150. So, do you see how this, you can almost like write in a natural language as long as you have gotten a feel for how to ask true-false questions? Filter the data frame MT cars, comma, okay, where horsepower is greater than 100 and where displacement is less than 150. So it's a really powerful function that lets us chain together a bunch of complex questions about our data set in pretty readable form. I mean, it's not as readable as English or Spanish, but it's you're talking to a computer, right? It's not a human we're speaking to, and so we have to kind of learn the syntax. But once you start getting a feel for this language, it starts making a bit more sense. I'm hoping we're starting to nebulously get to that point where when you see this line of code here, you can read it in your head as we're going to find the rows of empty cars where horsepower, the column named horsepower, is greater than 100, and in addition to that, the displacement column is less than 150. Okay, so your practice, I want you to mess with empty cars and come up with a bunch of random subsets over and over and over until it makes sense for you, okay? You can do stuff outside of the filter function, kind of like what you were talking about. We could set a new vector that's 100 through 105. Let's concatenate this. 100 through 105, and then 110 through 120. And so we made ourselves a new vector. It's just those numbers. And we can say filter, I'm just making this up as I go, which is what I want you to do. Empty cars, HP in new vector. What do we do there with those two lines?
That's showing us the rows, I guess, and columns that have the horsepower between 100 and 105 and between 100 and 120.
Yeah, and see, look here. It's showing us all the columns because filter doesn't care about columns. It's going to return all the columns for you.
Okay.
All it does is filter rows. So it lets you subset rows. That's what filter does. It does one thing. It does it really well. Our new vector here was just this set of numbers, right? 100 through 105. I did that a couple times for whatever reason, because probably I ran it twice. Okay. Oh no, it's because I'm an idiot. Let's say 110. Okay. So same response. It looked for something in horsepower, the column, in the data frame empty cars, and if it matched perfectly any one of these numbers, it gave us that row.
So
100.1 would not have matched because it wouldn't have been found in new vector, because new vector is just
integers.
So that works for horsepower. Let's try this. Let's try displacement with new vector.
Hold on.
Hang on a second. I'm just going to try something weird. New vector 2 is 160. That's it. Why did I pick that? Because I see there's a displacement here called 160.0. So now I'm going to try this. I'm going to change that to displacement. Say new vector 2. Hey, it did okay. It actually worked. I'm somewhat surprised, but I'm happy it worked. Okay. If I did 160L, hey, it still worked. R is always surprising me. Okay. So it found a displacement of 160. It gave us that. Okay. Your task is to get really good at filtering and to be able to use each and every one of these different logical statements in order to filter your data. along with and or. Okay. The reason for this becomes pretty clear pretty soon. We're going to have large data sets, and maybe we only want to look at, like a subset of students or a subset of our species we're interested in. Maybe we only want to plot things from a certain date or in a range of dates and put that in a plot. This is how you do it. What's nice about this, rather than just like deleting those rows from Excel and making your plot, is that we're not touching our underlying data. We haven't changed anything about MT cars. We're just asking questions about it on the fly. Okay. I see your hand up, Ernie. Is that on purpose?
Yeah.
Okay.
For assignment 4.
4? Yeah.
But it has to deal with files, right?
Yeah. So assignment 4 will actually walk you through that, but if you want a sneak preview, you should be able to figure it out. We've got the read.csv function. It's just one new function that you're learning. So I want you to explore that function. That's basically your assignment 4, is to like see how to use this function, which of course we do with question mark. Okay. So this is for us bringing in an outside file. Let me demonstrate for you. Since we're recording, this might be useful as you're doing the assignment. Read.csv wants a few things. It wants the name of the file, including the file path, how to get there, whether you want to keep the file headers, that first row, and then some other stuff like what do you want things to be separated by. By default, it's picking out a comma. You can see that right there. It's saying, yeah, keep the header row, separate things by comma, use a point for a decimal. If you're in Europe, they use commas for decimals, okay? So a nice file to play with. Data, fake grade data.csv, sure. What did it do? It showed me the contents of that file. It separated every time it saw a comma, sorry, it sees a comma, it makes a new column. It sees an end of line, it makes a new row. And so it's taking a flat data file and bringing it into R for us. CD, desktop, data courses on, data. If I want to look at this file by itself, fake grade data.csv, I just want to cat. This is what is in that file right there. We're going to see this a lot as scientists, things being stored as tab separated or comma separated. This one happens to be comma separated. I've indicated that with CSV. Just because I put a CSV doesn't mean it actually is separated by commas, so maybe take a look at it first to see. But R took this raw data here and read it in to R so it knows about things, except it didn't really, because I need to save it. So I can save it as an object. I'll call df for data frame. Now I've got all this student data with fake grades. Okay, so that's how you read in a file, and now we could even subset that. We could say filter df, where, let's see, the final project was over 180. Oh crap, was that capitalized or not? I don't know, so let's see, names, df. Yeah, it was capitalized. So where final project is greater than 180. Well, that's a bunch of students. How about where final project is less than 100? All right, we got 2 students there. Okay. So assignment 4 is all about getting to know this function without me teaching it to you explicitly. All right. You're going to find a lot of functions as we go on, and as you become like a lifelong learner of data analysis, you're going to encounter functions that you don't know how to use. I want you to learn how to look up the help file and play with them until you kind of see what they're doing. This one's a nice, safe one. It's fairly easy to learn. I think you'll be in good shape for assignment 4.
And is that due Friday?
Let's make it like Sunday night.
Okay.
Yeah. It really shouldn't take you too long. You're reading in some data. I made it tricky on purpose, so I'm trying to trick you. We'll see if you can figure it out. And then figuring out this and answering 6 questions, I believe, maybe 7 on Canvas, just kind of about this function. And so I think that's the main part of the assignment, is to answer those bolded questions.
And is the test also due on Sunday?
It's due before class. I'll give you a few extra hours. Before class on Monday. Okay.
Okay.
Does everyone have access to the test? You found the link and everything? Okay. Just a reminder from the syllabus, if you take this exam and you are pretty upset with your grade, that's fine, because your final exam in this class, you get to retake any test and overwrite your score. So it actually sometimes happens that people get like a 10 out of 100 or a 0 on this first exam, and they act like the world's ending. It's fine. By the end of the class, when they show up for the final, everyone's retaking the first test. Nobody like retakes the second one. It's always the first test that people retake. And the longest anyone has spent on it and gotten 120 out of 100 was about 6 minutes.
Because we learned everything at that point.
Because you learned everything.
And that's how
1,000
school
times.
should be.
Yeah, and so by the time you retake this first exam, it's like a 5-minute test. It really is. For you right now, no, it might take you a week, and that's good. That's fine. We're still in the learning process, but how fast it becomes, everyone's like leaving the final just like laughing, like, I cannot believe that I didn't know how to do this. Well, it's like tying your shoes. You know, a 1-year-old can't tie their shoes, but once you learn how, it seems kind of silly. You still have to learn it, and so we're in that process now. I don't want you feeling like too frustrated or upset if this is taking a long time. It's supposed to. It's supposed to hurt your head. That's the feeling of learning.
Wait, so you said that we get to retake a test on the final, or what?
Yeah, your final exam is you get to retake any exam, any previous exam, and it will overwrite that score. Yeah.
Awesome. Thank you.
I've never had anyone get less than 120 on the final out of 100, because everyone retakes the first exam and it takes them about 5 minutes.
Cool.
I have a question related to the exam, Dr. Zahn.
Okay.
Is there a way we could get feedback on our first couple of assignments before the exam's due?
You know what? Yes, I will do that tonight, like right now.
No pressure.
It's pressure. It's good. I've been lazy and like writing exams for my poor mycology class. They don't have near as much fun as we do. So yeah, I will do that. I will get feedback on those. I glanced through them and did get polls on everybody's stuff, and they look good. So I'm not too worried, but I will get it by tonight.
Thank you.
I mean, if you want to make
back of my hand.
If you want to make the mycology exams easier and just cut out some stuff so you have more time for this class, it's no problem.
Man, I've got some great evil questions for that mycology exam.
You said you weren't going to do tricky stuff, though.
It's not tricky, it's just evil. Yeah.
Dr. Zahn, so is the final timed? or
You have a
is-
week.
Oh, okay.
Yeah.
So all the tests are just writing and then pushing everything to
Yeah.
GitHub,
So
right?
all the tests you're going to have at least a week. I think the third test you might even get more time because I'm expecting a bit more on that one. Like writing some functions and stuff from scratch, and that can take some troubleshooting time, but expect a week to take each exam in here. Yeah.
Cool.
All right. Now, Ernie, if you want to stay after and share your screen, let's try to figure out what's going on.
Let's do that.
All right, I'll close my screen down. Oh, everyone, make sure you save the stuff we've been writing. Go ahead and save it. Stick it in a useful folder for you. If you want to make like practice scripts or assignment or like lesson scripts folder, and just save it in there so you have access to it if you want to see it again.
Sorry, I missed the last part. You said make sure to save it. That's it.
Yeah, so let me share. I'm gonna this script we've been working on in class. You've been typing along, I hope.
Yeah.
Maybe I should have been more explicit.
No, yeah.
With that, I mean, you've got a lot of info in here that you took time to write, so just save it. And I'm here in Data Course On. I'm going to go ahead and make a new folder and just call it like lesson scripts. And I'm going to save it as like week 4 part 2 or whatever .r.
Okay, so under data course underscore your last name.
Yeah, and because that's where we're going to be working, that way all the file paths will work, so I'll just keep it in there, right? Lesson scripts, or I can just even leave it in here as a, I don't know, wherever you want to save it. Just kind of like make sure you have access to it, so 2 weeks from now you're like, wait, didn't we learn a way to filter MT cars with the in? Like, I think I remember typing that. You'll have it with you.
Okay, perfect. Thank you.
All right, so I'm gonna stop sharing my screen. Okay.
There you go.
Okay, yeah, there is no Git tab there. You're in data course. You've got. All right, open up your terminal again.
Should I open it from here or?
Actually, yeah, down on the bottom there, there's that little terminal tab next to console. Yeah. All right, now try PWD.
Wait.
Yeah, that's good. So you're in there. And now git space status. I want to see what the message is here. Man. Have you pushed any of this to GitHub?
I have pushed the assignment 3 because that was the homework for Tuesday. Or
scroll up a little bit. Yeah. Your branch is up to date with origin master. Okay, so now do cd space .git. Okay, and now type in cat space config on lowercase. Okay, yeah, it's got your URL there. Ernie VC. 1 second.
data course.
I'm still with you. I'm Googling right now.
Yeah.
Okay. Are you Windows?
A Mac.
Mac. Okay. In your terminal right there again, type in which WHICH space git. User local bin git. Okay. All right. So now go to the top of RStudio to like the options. It's in profile. Oh, right. Sorry. Tools, global options.
Tools, global options. Yep.
Yeah. Okay. Now, on there, go to the Git SVN. Okay. User. There it is. Okay, so that's the problem. So in the top one there, it says user bitgin, but user bin git. You want to change that to user local bin git. So yeah, browse should work.
User local.
You want it to match the output from that terminal. See how they're different?
Yep. Bin. And then
User local bin
git. Okay.
Yeah. Apply. Okay. Now you got to restart RStudio.
I'm just gonna close it.
Yeah.
Let me see. RStudio. Cross your fingers and your toes, and it didn't.
It's got to work. It's gonna work. Well, as soon as you open your art project again.
Oh, file, open.
Yeah.
Or let's see.
The easy way is the top right, the project up there. It'll show you your most recent stuff.
Which one?
It says project none above that, actually, a little bit like the far right. Yeah. And you can just click on data course below. Yeah. There.
Oh,
There's
cool.
it. Sweet.
Thank
Awesome.
you.
No problem. All right. Practice. I'll see you on Monday.
Okay. Bye.